Hi and welcome everyone to our course for wind energy design. Hope this course will be helpful for you in your own career. So in our first lesson of wind energy course, we will discuss an introduction to wind energy. So first, what is wind? Wind is simply the air flowing in our area. As you can see here in this image, this is the image where wind is flowing. So simply wind is a natural movement of air of any velocity on the surface of Earth due to the presence of difference of pressure. Okay, due to the presence of difference of pressure between one area and another, the air will start moving from this location to another. Okay, now the question is, why do we have difference in pressure? The difference in pressure between one location and another is generated by the uneven heating of the Earth's surface by the sun radiance or radiation. Okay, so we have the solar radiation. This is our Earth. Okay, this is our Earth, and we have the solar radiation. As you know that at the equator, at this line, the equator, you will find that the temperature is very high, or it is exposed to a very large amount of solar radiation. So in this location, we will have very high temperature, okay, which means that since we have high temperature, it will lead to low pressure, okay, or rising of air, okay, low pressure. So as you can see, rising air, low pressure in this location. Now, if we go to the North and South Pole, in this North and South Pole, you will find that we have high pressure. Why? Because they are less exposed to the solar radiation. So this will lead to cold air, which will lead to high pressure. So in the cold areas, we have high pressure. In the warm areas, we have low pressure. So due to the presence of difference between high pressure and low pressure, difference in pressure between these two locations, the air will start moving from the high pressure region towards the low pressure region. Okay, so as you can see, air will start moving, or the wind will start blowing from the high pressure area to the low pressure area. Okay, same as here, high to low pressure. Now in this location, when it starts to cool, when the warm air wind coming from here to here starts to becoming warmer, or its pressure decreases, it will return back to the high pressure area. Okay, so this cycle keeps repeating itself. So as you can see here, the air moves from area of high pressure, such as the North and South Pole, to the area of low pressure, such as the equator. So when it moves from one location to another, it forms what we can see here, the wind. Okay. Now, as you can see here, we have cold area, cold air, or cold area with cold air. It has high pressure. And we have here an area exposed to the sun with low pressure. Okay. So the air starts moving from the high pressure area, cold area, into the warm area. Okay, so the pressure, high pressure to low pressure. So the wind starts blowing. Now, when it reaches the low pressure due to the presence of warm air, it will start heating up and start moving upward. Then we'll go back to the cold area, like this. Moves from high pressure to low pressure, then from low pressure to high pressure. Now, as an example, as you can see here, this is our Earth. Divided into several regions. You can see the North Pole and South Pole. You will find that this area is having high pressure due to cold air, and this one have a low pressure, more heat. Okay, so the difference between two areas from high pressure to low pressure, the wind will start blowing. So it moves from the high pressure going to the low pressure. Then here it will start its heat, or its temperature will increase, its density will decrease and go up, then return back to the cold area. So as you can see, the cycle repeats itself in every location on Earth. You can see high pressure, low pressure, high pressure, low pressure, and so on. So between these different areas, the wind will start moving. Another thing, which is the land breeze and sea breeze. So as you know that during the day, you will find that this area will be hotter than the sea. Okay, sea will be cooler. So we have here high temperature and we have here low temperature. So what will happen is that the air will start moving from the cold area towards the warmer area. Okay, from the high pressure area towards the low pressure area. As you can see here, high pressure zone, wind start moving to the low pressure area, which is the warm area. Okay, then when this cold air comes here, it will be heated or exposed to solar radiation, so it will start rising up, then it will its density will decrease, then it will go back here, then it will sink down because we have here cold air, so it will go down and then it will repeat itself. So as you can see here, cycle repeats itself. At night, the reverse will happen. The land is cooler and the sea is warmer. So this has a high pressure. Here we have lower pressure. So it will move from here going to the sea, then it will rise up, then go back, and so on. Okay, so this difference in pressure leads to the generation of wind. Now, what does wind energy mean, or wind power mean? The wind energy is simply the process of converting this motion or the wind motion into mechanical energy, or from mechanical energy then to electrical energy. Okay, so let's understand this. As you know that this is called a wind turbine that converts the motion of or wind into electrical energy. Okay, wind into electrical energy by converting the first wind to mechanical, then mechanical to electrical. Okay, so what happens exactly here? First, the wind passes over the blades and makes them turn. This is called the blade. Okay, this one is called the blade. So we have 1, 2, 3 blades. This one has 3 blades. Now, when wind comes through it, it will start rotating. Okay, as you can see here, when wind comes through it, it will start rotating. Okay, we have 1 blade, 2 blades, 3 blades. Okay, now second step is that the blades turns a shaft. Okay, you will see here a box here. Inside this box you will find a shaft. Okay, so when these blades start rotating, they will cause the rotation of a shaft. As you can see here, these blades rotating, you will see here a shaft. Okay, a mechanical shaft. Now this shaft will produces mechanical power due to the rotation here, produces mechanical power. Now if we take this motion and connect it to an electrical generator, we will have electricity. Okay, so here we have the shaft turns a generator which converts the kinetic energy of the blades into electrical energy. Okay, now sometimes between them you can see here the blades starts rotating. Now this blades, the shaft here connected to the blades, this shaft is connected to a gearbox. Okay, as you can see here, this one is called gearbox. What is the benefit of this one? It converts the low speed of the turbine into very high speed, okay, for the electrical generator. Okay, so as you can see, this wind turbines rotates slowly compared to the speed required for the generator. So the gearbox here, this one, increases the speed of the second shaft. You can see this one is slow, this shaft is very fast. Okay, due to the presence of this gearbox. So we will have a very large velocity for the electrical generator, which will lead to generation of electricity. Okay, some types of wind turbines have a gearbox, others don't have, and called direct drive. Okay, they don't have any gearbox. Okay, Then the electrical energy produced from this generator is connected to a transformer. Okay, what is the benefit of the transformer? The transformer is used to step up the voltage required for the grid. Okay, so 5, the electricity is exported to the electricity grid using the transformer. Here the transformer is connected to the power grid. Okay, so this transformer increases the voltage required for connection to the power grid. Okay, so the wind motion causes the kinetic energy of the wind causes the rotation of these blades, okay, which is connected to a shaft, then gearbox, then electrical generator, then to transformer and the grid. Okay, so this is the process of converting the wind energy into electrical energy. Now, the first wind turbine which was used for electricity generation was made by Charles Brush, this man, in 1888. Okay, this is the first wind turbine. Okay, this turbine consisting of 144 blades. As you can see, 1, 2, 3, 4, very large amount of blades, which mean it will have very large weight and small velocity. Okay, so this one was connected to a gearbox which was used to run a DC generator. So it was used to produce DC power. So the mechanical motion of the wind turbine or the blades were converted using a gearbox and connected to a DC generator to produce electrical power. Okay, so this wind turbine had a power of 12 kilowatt. The generator has a rated power of 12 kilowatt, and the rotor diameter, the diameter of this rotor from here to here, the diameter of this rotor was 17 meters. Okay, this was used for 20 years to charge batteries inside this location. Okay, so the DC generator produces DC voltage which was used to charge batteries. Okay, that was the first turbine used. Now here are some sizing for different wind turbines and classification of the wind turbines according to their size and application of each type. So we have small, we have medium scale, we have large scale, which is land-based, and the large scale, which is offshore. Okay, the small, what does all of this classification? We have many classifications of wind turbine. This classification according to the rated power. Okay, so this one is having, or the small type has a power less than 100 kilowatt. Okay, small amount of power. This power is used in homes, farms, remote applications such as water pumping system, telecom sites, and so on. Okay, so this is used in very small applications. Okay, not for grid, for small applications. Now this wind turbine is medium scale, from 100 to 1000 kilowatt, or from 100 kilowatt to 1 megawatt. Okay, this one, which is a medium power, is used in powering a village or in hybrid system, which is consisting of solar and wind, and can used in the distributed power or distribution of electrical power, the distribution network. Okay, now the large scale, it can be consisting of many wind turbines. Okay, not only one but several wind turbines which can form a farm. Now the large scale, this one, which is land based, it is located on land or mounted on land. This one is used in utility. Okay, so they can be used in large distribution network, and they can be used to connect to the power grid. Okay, now another one which is large also but offshore. Offshore means they are in the sea, not on land but in the sea. This one has a rating from 3 to 7 megawatt. Okay, it is used in the utility scale, also wind farms, okay, and they are used to connect to the power grid. Okay, so this is the classification and application of different types of wind turbines according to their rated power. Now let's see the evolution of the US commercial wind turbines from 1980 to 2015. Okay, so as you can see, as time passes, we started with 50 kilowatt rated power of the wind turbine. Then as we go up with years passing, we have reached up to more than 5 megawatt. Okay, so we reached more than 5 megawatt for the offshore types. Okay, so as time passes, you can see that the rated power increases, and also in order to increase the rated power, we need to increase the rotor diameter. Okay, you will understand the effect of rotor diameter in the next lessons, but for now, as the rotor diameter is larger the diameter of the rotor, the more wind it can capture, or more kinetic energy it can capture from the wind. Okay, so as you can see, more power means larger diameter of the rotor, okay, leading to higher capture of the wind or more kinetic energy. Now here are two types, onshore and offshore wind farms. Wind farm means group of wind turbines connected together. You can see this construction is called wind turbine, which is used to convert the wind energy into electrical energy. We have another wind turbine, and so on. All of this are connected together in the form of a farm. Since they are on land or mountains or hills, they are expressed by, or its name is the offshore wind farms, okay, or onshore wind farms. Onshore means they are on land, okay, and offshore, which means they are in sea. You can see here offshore farm, which is in the sea. Okay, now as you can see, the onshore, which is on land, you can see this is a large farm consisting of several wind turbines. Okay, this farm is onshore on land. This farm, the onshore, can be for wind farms on mountains, hills, and so on. The offshore, as you can see, this is a farm which generates large amount of power. This farm is inside the sea, okay, or offshore. Now, the future expectation for wind turbines for offshore and onshore. For the onshore, we currently in 2019, we had a maximum capacity of 2.5 megawatt, which have a rotor diameter of 120 meters. And the hub height means from this location, from this nose to the ground. This is called hub height. The hub height was 89. Okay, now the expectation for 2035 is that we can reach up to 5.5 megawatt, which almost more than double this value, with a rotor diameter of, you can see, more power means larger diameter and larger height. Okay, so as you can see, the height became 130 meters. This is for the application of onshore. Now for the offshore, which is in seawater, you can see we have in 2019 we had 6 megawatt of 150 meter and 103 meter. Now for 2035 we expect to reach a wind turbine of 17 megawatt, which have a rotor diameter of 250 meter and hub height of 151 meters. Okay, more height and a very large diameter. Okay, the only problem in the design in general of wind turbines is the rotor diameter, the limitation in rotor diameter due to its large weight and transportation problems. So in this lesson we discuss in an introduction to wind energy system, the meaning of wind, how we can convert the wind energy into electrical energy, the evolution of wind turbines, the application and size of different wind turbines, and the future expectation of wind turbines. In the next lesson, we will discuss the types of wind turbines and which one we use in wind design or wind energy application design.